Hi students, I am Miss Dea El Mundo, and today I will be discussing to you our first lesson for grade 10 science, which is all about the lithosphere. Are you excited? By the way, this lesson is anchored with the division made module of SDO Caloocan for grade 10 science, week 1, entitled Lithosphere, the Rocky Skin of Earth. The most essential learning competency to be tackled here is describe and relate the distribution of active volcanoes, earthquake epicenters, and major mountain belts to plate tectonic theory with the code that you can see on the screen. In this lesson, we would also like to describe the Earth's lithosphere and differentiate oceanic and continental crust, infer that the Earth's lithosphere is divided into plates, identify the major lithospheric plates, and determine the scientific basis for dividing the lithospheric plates. So, without further ado, let's start our learning for the day. Let me show you a picture. What is this? Correct, it's a world map. What can you see in a world map? That's right. In a world map, you can see countries, continents, oceans, islands, all with different colors. I'm sure that you are very much aware of the different features of a map since you have been using this in your lower grades, especially in your Araling Panlipunan subject. Now, let's see the next map. Have you seen this map before? What is this map all about? Is the world shown in the first map different from the world shown in this map? Now, let's place them side by side. As you can see, both are maps of the world. However, the first map, which you can see on the left side of the screen, shows the waters that we have. When I say waters, I mean the seas and the oceans. The map on the right, on the other hand, only shows all the plates in the world, which includes all the land and even the land below the water. And we call all this land the lithosphere. Let's inspect the right map further. In this map, we can see tectonic plates and plate boundaries. The smaller sections of the lithosphere are called tectonic plates. This yellow plate is one tectonic plate. This brown land is also one tectonic plate, and same with this small pieces. They are all called tectonic plates. Plate boundaries, on the other hand, are edges that separate the tectonic plates with one another. If this is one plate, the Pacific plate, and this is the Nazca plate, which is another tectonic plate, then the line in between them is a plate boundary. As we can see in the map, there are lots of plate boundaries all over the world. Now, let's go to the different types of lithospheric plates. What are the two types of lithospheric plates again? Correct. We have the continental lithosphere and the oceanic lithosphere. First, let's discuss the continental lithosphere. The continental lithosphere is thick and is found under land masses. It has an average thickness of 25 to 70 kilometers and is composed of old rocks. It has an average density of 2.7 grams per centimeter cube, and majority of the rocks that make up continental lithosphere are called granite. So this is how a granite looks like. On the other hand, for oceanic lithosphere, it is thinner compared to continental crust or continental lithosphere with an average thickness of 7 to 10 kilometers. It is younger, according to studies, than continental crust and is denser with an average density of 3.0 grams per centimeter cube. Now, if continental lithosphere is usually made up of granite rock, oceanic lithosphere is usually made up of basalt or basalt rocks, which looks like this. Here is another diagram showing the continental crust and the oceanic crust. As we can see here, the continental crust is much thicker compared to the oceanic crust. However, the oceanic crust is denser or has greater density compared to continental crust. And in this diagram, it can be seen that the lithosphere is made up of both the crust and the upper mantle. Now let's try to fill in this table comparing the different characteristics of continental lithosphere and oceanic lithosphere. First, the relative age. Which is older and which is younger? Correct. Continental lithosphere is older than oceanic lithosphere. How about the relative thickness? That's right. Continental lithosphere, although it is older, it is thicker than oceanic lithosphere. Next, the relative density. Which is denser? Okay, so oceanic lithosphere is denser than continental lithosphere. If you remember the numbers, the average density of continental lithosphere is around 2.7 grams per centimeter cube, while an oceanic lithosphere will have an average of 3.0 grams per cubic centimeter. Finally, the type of rock. Very good. Continental plates or continental lithosphere are mostly made up of granite, while oceanic lithosphere is made up of basalt or basalt. So now you have already learned the basic differences between continental lithosphere and oceanic lithosphere. Let's now move on to the different types of plates. We have two types of plates. We have primary plates and secondary plates. Now, what do you think is the difference between the two? Okay, so primary plates are called primary because they are larger than the secondary plates. So that is only or basically the difference between the two. The Earth has 7 primary plates and 8 secondary plates. Given the map here, can you name some primary plates? Okay, so the Earth's primary plates are, of course, the Pacific Plate, the North American Plate, Eurasian Plate, African Plate, Antarctic Plate, Australian Plate, and South American Plate. Now, what do you notice about the names of these primary plates? Very good. Most names of these primary plates are taken from the names of the continents, except Pacific Plate. However, Pacific Plate is the plate that can be found under the Pacific Ocean. On the other hand, Eurasian Plate is like the combination of Europe and Asia, which basically sits on the same tectonic plate. So now let's go to the secondary plates. Can you name some of them? As stated a while ago, secondary plates are smaller than primary plates. The secondary plates are Juan de Fuca Plate. Can we find Juan de Fuca Plate? This one, this small plate. Nazca Plate. Cocos Plate. Caribbean Plate. Philippine Plate. Arabian Plate. Indian Plate. And Scotian Plate. See, they are very easy to find because you can distinguish primary plates from secondary plates by their sizes. Now we are done with the different types of plates according to composition and then the different types of plates according to sizes. Let's go now to this question. What is the basis of scientists for dividing lithospheric plates? Okay, how did they know? Is there really a physical boundary between these plates? How did they know that the shape of the Arabian plate is like this? How did they know that the Philippine plate is just this one? Okay, we know that the Philippines is not with this shape because the Philippine is an archipelago, but then how did they come up with these divisions? Any wild guess? To help us answer that question, let's look at these pictures which can be found in your modules. The first one is the map of distribution of earthquake epicenters, which are shown in the darker areas. So this means that these darker areas represent areas where most of the earthquakes occur. So of course, other areas would also have earthquakes, but then most of the earthquakes would happen in this dark area. Next, we also have the map of volcanic activities. Now, what do you notice? Okay, so just like the map of the distribution of earthquake epicenters, the second map would also show points or places where there are more volcanoes or volcanic eruptions compared to other places. For example, this area has more volcanic activities compared to the center of this area. And we also have other volcanic activities in these places. Third, we also have the map of the major mountain ranges in the world. The third map is quite different from the first and second map because the center of the map is not the Pacific Ocean. As you can see, the Pacific Ocean is divided into two places. Instead of being in the center, the Pacific Ocean is found on the left side and on the right side. But then, as you can see, most of the mountain belts are found in this area and in these areas. Alright? Now, can you see any similarities among the three pictures or diagrams? Okay, I'll give you 20 seconds to think of it, and if you are done, please comment your answers on the chat box. Okay, so you said that most of the highlighted areas are found in the Pacific Ring of Fire. That is correct. So the one being shown in the second map is actually the Pacific Ring of Fire. Okay, so we can say that the three geologic events and features that are being shown in the three diagrams, which are the earthquakes in the first map, active volcanoes in the second map, and major mountain ranges in the third map, they are distributed near or along plate boundaries. Okay, so if we compare, for example, the second map from the first map that you have been seeing a while ago, if you will look at the boundaries of the Pacific Ocean or boundaries of the Pacific Plate, it is very similar to the marks showing the active volcanoes. Okay. Also, here we have the Nazca Plate. Okay, you can see here that there are dots that seem to be part of a line or a boundary. So therefore, we can say that scientists have been using these events and features as basis for identifying the plate boundaries, because of course these plate boundaries are not there in the first place. Okay, so scientists have to gather lots of data, which includes earthquake data, volcanic eruption data, and the present mountain ranges in order for them to plot these plate boundaries. Alright? So, any questions? So, if there are no more questions, this would be the end of our discussion. So I hope you have understood the lesson for today. And if you have questions that you are just shy to ask about, please don't hesitate to send me a message or post as a comment, and then I'll try to answer them as soon as I see them. So that's all for today. Goodbye and thank you for watching.